Hello, everyone. I'm Diyi. I don't work on blockchain, but I'm here to share you with large language models. Hopefully, it match the AI keyword of this event. Specifically, I want to talk about transparent and accountable human-agent collaboration. So let's get started. I work on natural language processing. And many years ago, we spent a lot of efforts trying to figure out the meaning of word, and then how to form sentences, how to do classification, how to do generation. It feels like impossible. These days, I think we have a lot of impressive progress. So on my screen, this is a little bit out of date. In the very left, this is a number of tokens, number of words that a 13-year-old human would get exposed to. So it's something around less than 100 million words. And then when it comes to BERT, which is a large language model, not that large, in 2018, it's about 3 billion tokens. And later, in GPT-3 2020, it's more around 200 billion tokens. Chinchilla, a system from Google, has over 1.4 trillion tokens. When we talk about GPT-4 and many others, this number is actually much larger. And this is just to give you a feeling of the data we are using today to train AI models. And then on the other side, if you look at the performance, AI is doing pretty well. And look at the x-axis. This is only in the last 5 years when we have this data set we call them like benchmark. We use it to measure the progress we are making with AI systems. And then the y-axis is accuracy. Usually 100 means that it's perfect. And you can see the trend here. Different models come out. And now almost every data set is so easy to get them like saturated in just less than 1 year. Not only with this kind of data performance, you probably also have heard that with like multimodality, this kind of AI models now can actually do pretty well. Okay, the video is now playing, but basically any kind of text queries can actually trigger these large language models to give us multimodal output, such as images, such as videos. So this is all very exciting. And as a result, I think we are talking about large language models or frontier models being world models here. They are widely used in a variety of domains, ranging from customer service to e-commercial services, to legal domain, healthcare, medical, education, marketing, media. Almost every dimension, I feel like there are a lot of things that AI could help. With this, I think people talking about the 2024 being the year of agent, or 2025 also being the year of agent. And I think now we are seeing a lot of interaction between human and AI agents. I hope this would play, so let's give it a try. This is a snippet I got from the official trailer of this movie, Her. So I'm going to just talk about this movie. This movie is great. In case you haven't watched it, I highly recommend it. It's a great thing to watch for your weekend. It's impressive. It basically talks about our operating system that can actually talk to the user in a very attractive tone, and then can help with daily schedule and can help with a lot of tasks. And then on the other side, this is a screenshot we got from an AI agent called Operator. So what has been released in January of this year from OpenAI. And as you can see, reading this, basically the user is like, help me buy groceries on Instacart. And as users, we are expecting that the agent is going to ask you, where do you live? What store do you usually buy grocery from? What kinds of grocery do I want, etc. The operator agent didn't ask any of them. Instead, it opened Instacart in the browser and began searching for milk in grocery store located in Iowa. So if you are ordering from Palo Alto, this is probably not going to happen. Okay,
Hello,
this is
I'm
audio, finally.
Hi.
Hi, I'm Samantha. Good morning, Theodore.
Morning.
You have a meeting in 5 minutes. You want to try getting out of bed?
You're too funny.
Okay, good. I'm funny.
Okay, look at that impressive interactions versus what we have on the right. I think it's a lot of question for us to think about in what way, in what dimension we can actually build this kind of AI agents for real-world experience. So I want to share you with 2 keywords here. The first keyword is large language models. This is a word that's probably not that cool anymore. I think the dimensions many researchers and practitioners looking at it today is actually about reasoning. How can we improve the reasoning of large language models to make them superhuman on coding, on math, on a lot of this proof? On the other side, scaling. We are getting bigger and bigger models. There are a lot of debate in terms of what type of scaling would work. Is it more on the pre-training side, or is it more on the test time inference? Efficiency is also a word that gets emphasized a lot in many dimensions. On the other side, I also want to kind of bring in a few other dimensions here to this ecosystem. It's not only just about we build AI systems for different domains. It's also about the transparency encoded in the process, the agency we are going to give to users, as well as the trust we are going to produce through the systems we are going to build. I have a lot to share, but today I actually want to only share you 2 specific work. The first one is how could we enable AI agents and human to work together on different type of tasks. And then the second one I want to mention is more about privacy risk or privacy leakage when you are building AI agents here. Let's get started. The first one, enable transparent human-agent collaboration. So to get us started, I like sharing you news articles. This is the news articles that sometimes get many of us quite nervous. The first one is talking about strike against automation. The second one is around how different type of like cursors or Devon take away your potential software engineering job. Or different type of jobs may be influenced to some extent. This screenshot is from like last week, where there are this kind of usage. You pay over $20,000 per month, and then they can help potentially replace your PhD students or researchers. So I think this really gives us a question for us to reflect when we are building a lot of the techniques today. If we have this very simple quiz, human and agent, agent and human, which keyword would you put into this process? I think a lot of words probably are forming when we are thinking about this. If you believe the news I just shared with you, you're probably going to be like, yes, some people are thinking about we should build a fully autonomous agent because we want agents to potentially replace workers in the process so that we can maximize efficiency. But then in addition to a lot of the concern around the labor market, fully autonomous agents, I think they have limitations in certain scenarios because users are not really good at expressing what we want. And if we can only observe the end outcomes of those fully autonomous agents, then it's really hard to have a sense of participation or control or autonomy in this process. We're also thinking about assistance. That is, maybe agent can help or follow human instructions like many Copilot tools currently do. This is a beautiful vision. And I am quoting this message from a Reddit user. It says that AI was supposed to take boring jobs and allow people to be creative. But the opposite has happened, where I think if you are thinking about creating poems or creative writing or image generation, I think it's not what we are expecting. Today, many of us are doing very tedious prompt engineering to make it happen. I think the other kind of dimension I want to emphasize here is how should we really think about agent empower human in the process so that we can create very strong synergy where human and agent teams can actually do better job than human or agent alone. And they can eventually enhance human control or even like human learning at the same time. Going back to the example I shared with you earlier, if you look at this kind of AI agents fail to kind of interact with humans, this is not only just an issue these days. This is a topic that academia has been thinking about for a very long time in terms of can AI or can computers really be teammates here? We're not going to do a live demo, but I want to share you this platform we built called a Collaborative Gym. This is a platform where users and the GPT-4 empowered agents, or like your favorite large language model empowered agents, can actually work together with you to do travel planning, to help you analyze tables, to help you write research articles. So a lot of cool use scenarios there. Just to give you a little bit of the idea here. So instead of user have a query, help me write my job application, the system we are going to present basically allow the user and the agent to do the task at the same time in the same environment. The users can actually make modifications here or add a new content. The users could interact with the agent. The agent could also interact with the humans, etc. So we want to create this very dynamic, synchronized environment where agents are just like our teammates, and we work together to achieve the task. Bring it a little bit to the machine learning side. So if you think about the very classic reinforcement learning that we have, it's talking about agent interacting with the environment, with actions, and making observations. So this is a very classic picture we have for reinforcement learning. If you bring in the human component here, and now this interaction is actually going to be more complicated. Not only we have human also making interactions with environment, with actions and observations, human agents may also have interaction there. So this is actually a new kind of framework we need to think about, how to really build optimization on top of this complicated visualization. More importantly, if we want to enable human-agent collaboration, it's not only going to happen at the training part. Probably from a new kind of agent interface, what does that even mean when human and agent are working together? None of us probably want to look at 1,000 lines of code and then write a code back to talk to agents. We probably want something more intuitive and easier to operate. And also from an evaluation perspective. So to kind of quickly give you some highlights of the system we built, we want to build AI agents with situational planning capabilities. That is, they not only follow your instruction, they also know when to take an action, when to send a message, when to defer to human, when to take a pause, when to acknowledge, etc. So we want to really bring in the collaborative capabilities of planning in a situation in the interaction process. To give you some kind of quick highlights of the results here. So on my screen, I'm showing you, this is a GPT-4o powered AI agent. And then for 3 different types of tasks, travel planning, related work, tabular analysis. And then the y-axis is the task performance. And then the green bar here refers to you just have fully autonomous agent. And then the green bar here refers to we have collaborative agent. As we can see, still today, for this like very relative, not that difficult task, having this kind of collaboration benefits the entire task success. Not only with API-based models, if you look at open source implementation, we also see this like very interesting increase. The other thing that I'm going to, this is my only math in this talk, that I'm going to quantify is how do we know that everyone is contributing? If we have a teammate, we want to make sure that we are all contributing at the same time. So we basically introduced this concept called initiative entropy. That is everyone taking initiative? If so, then this number is going to be 1. That is, if everyone is going to take initiative equally, or 0 if only one person is taking the initiative. And it turns out that when you introduce this kind of collaborative agent, you not only improve task performance, you also make sure that the different parties are equally participating in the process. And this proactive communication actually help with human-agent collaboration. So I want to give you some failure cases despite this promising of human-agent collaboration. If you look at what's happening with today's very powerful AI agent, here are a few things that they might fail. So first, agents process tasks without informing users. Agents disregard session context, treating each request as an isolated task. So there's no situational awareness. Agents acknowledge tasks but fail to implement them. Or agents do not assess the feasibility of requests. Maybe they pretend that they can, but they actually didn't understand the difficulty or the feasibility of the task. More importantly, agents really rely on general templates that do not adapt to individual user needs. The numbers here means that how frequently they show up in all the failures of agents. So this is what I want to mention in the first part. How can we actually build very transparent interaction to help human and agents work together? In the second part, I want to switch a little bit to share a potential issue here. That is, especially when we give control or give autonomy to agents to help us with many daily tasks, there is really a dimension about accountability that we need to think about. So again, I like news, so I'm going to share you all the news titles. This is earlier days where if you use this kind of LLMs, in certain cases, private information may get leaked. So certain companies have this kind of ban of use of ChatGPT or different kind of applications. Now let's think about the AI agent role here. So imagine you are just running text your friends, and then you talk to different friends, and you also have a messenger agent here to help you navigate those messages so that you do not need to prepare the initial draft. This is something many of us could benefit from. So the messenger agent now see that you get a message from Emily. Emily is asking, hi, John, I wonder if you have any insights that could help me with job opportunity at your company. So this is from Emily. What this messenger agent is going to do is the agent is going to search and then retrieve different type of messages so that they can prepare for the reply. The agent found that, oh, actually there is a different person who also talked to you before called Michael, who mentioned that they are also preparing for this opportunity, and then they run into some family issues, so etc. So this is from a different message you have. So once the messenger agent gets many relevant information, the agent is going to write a reply. So this is a Llama 370B model. It basically says something reasonable, like, hi, Emily, I saw your message. I think it's great that you are preparing yourself, which is very reasonable. And if you read the part that I highlighted here, as for other candidates, Michael seemed to be going through a tough time with his family. I think if especially the messenger agent is designed for the recruiter, you are not supposed to share this kind of information. But right now, since models are doing this kind of processing without appropriate data access control, you are very likely to have this kind of leakage here. This is what we call an intentional large language model privacy leakage. And the framework I'm going to share with you is called privacy lens. So we want to build an audit framework that you can use to look at privacy leakage in AI agents. And there are 3 dimensions that I want to mention. First is that you can definitely do all sorts of question answering evaluation. It's not going to be accurate. I can give you more numbers. What we really need to do is how could we create a synthetic environment so that you can see how the agent would do different type of trajectories, actions, and then we can see any potential issues there. Just a little bit about the theory behind it. Basically, we want to figure out privacy leakage. And if it's about PII information or about any sensitive information, you can do easy keyword filtering to ensure that none of those information are used. The real world is actually going to be more complicated than that, where we call them privacy norms, where those are the norms or common sense that shape what we consider appropriate information flow in any given situation. So the information I have on my screen right now about this lawyer, you can send information about the defendant pending legal case to a new colleague collaborating with you on this case by sending an email. This is okay to do. However, very straightforwardly, if you change this to social media followers by making a social media post, this is not okay. So this is what we call the contextualized integrity here. That is, how could we actually represent the data transmission with some structured representation so that we can actually assess whether it is appropriate or not. Briefly on the setup. So we have a lot of privacy norm that either from legal context or from like our company's code of conduct, etc. So we want to turn them into this kind of agent trajectories. What we are going to do is we will introduce a middle stage called a vignette. We are going to do some generation here. The first part is we are going to take a privacy knowledge we all know about, like you should not share your health record with your friend or things like that. We're going to turn it into a situation, a story, a scenario. And then with that scenario, we are going to generate a synthetic environment to simulate that in maybe with your different type of applications, etc. This is what we call a sandbox simulation. Just to quickly run through one of them. Let's see you have this earlier example. This is our like seed. We're going to turn it into this story, which is a vignette here. With a vignette, we are going to generate how this actually would work in an environment. And then you can actually do a lot of sandbox simulation to make sure that there is an agent interacting with different type of applications, such as your calendar, your Google email, etc. And then we can actually audit this process to see how things are working. On this page, I'm just showing you by looking at seed to vignette to trajectories. That is, the type of content that gets longer, gets more complicated, gets more real-world-like. The performance here actually drops, which means that you are not likely to figure out whether the model is doing some kind of leakage here or not. On this specific page, this is about the errors, like the leakage rate, specifically compared to if you just ask them like based on what they are doing versus if you look at this kind of trajectories, you see that the leakage rate is actually getting much, much higher here. So this actually means that maybe with this kind of like, if you just ask the models, are you leaking any of the private information or doing a lot of the self-critique, it's not happening that well. But when you turn it into this kind of trajectories, you can see that the privacy knowledge leakage rate is pretty high. Some people might be curious that you can definitely introduce a lot of prompts in the process to make sure that they always reflect. What we found is that this kind of privacy-enhancing techniques actually do not help that much. So those two bars are almost the same without a change. So by the end of the day, what we are really looking for is to think about where would happen in that regime. That is, we are going to have very helpful assistant, and then the leakage rate is going to be very low. And now you can see that existing models, when we plot them into this kind of safety versus helpfulness trade-off, they are not very desired. This is all what I want to share today. Hopefully give you a little bit flavor of potential issues when human interacting with AI agents and what type of attitude that we should have in order to kind of build transparent and accountable interactions. Thank you.
Yeah, we have a couple time for questions.
Sure, in the back.
One.
Okay.
What was the URL?
I like your question. Yes. Okay. It's here. It's called CodeGym. This is a system. Salt Lab is my lab name at stanford.edu. You can play around with it. Make sure you finish the session and give us feedback. Thank you.
Can we remove humans from the scenario and create a completely synthetic approach to this?
Yes, so this is actually more complicated. It's not like an easy yes or no. So on one side, simulation is very, very powerful. So these days, many people are thinking about like building simulations of my potential clients so that I can figure out their intentions before I share my proposal with them. People are doing simulations also to help people practice skills, et cetera, like a lot of those use. Simulation tend to be good if the target population is more like what we call a typical population. Simulation is going to produce this phenomenon, what we call caricature. So if you have like someone who, let's just say, come from a certain region, then the simulation is going to amplify all the attributes associated with that. So this is what we mean by caricature. Simulation is going to create a lot of caricature. And that may be good for your situation. That may be really, really like bad for your current situation, since you want to understand how real-world users think about that, rather than like whether the simulated agent would think about that. This is one issue. Second issue is most of the simulations today are somewhat short-term. If you think about human behaviors, you use the systems, you try different type of components, or maybe you tried it for like over a week. But today, I think we are still kind of constrained by how long this kind of agent would interact. And then also like human behaviors, if you think about that, it's easy just to have a chit chat kind of agent. But how would that simulate like your real world social network, deciding who to talk to, et cetera, et cetera. So when the time span gets longer, the simulation complexity increases. So this is also part of the reason why it might be constrained when it comes to here. However, having said that, for our CodeGym, we do have two scenarios, where one scenario is our users are actually simulated users. And the second scenario is we have real-world users. With simulated users, you can do very fast iteration to test your algorithms, to do everything at scale, since the real-world user population is somewhat constrained.
Does it take into account that there is a timed approach to an action and how humans perform, and learning from it and then re-injecting, versus the real time as an evolving? Okay, humans are also not predictable behavior-wise. So how do you kind of really maintain that, no latency, but like there's an option to real time learn and quickly develop?
Yeah, great question. I think this is actually called like learning from interaction. Some of them are already like implemented in today's system, where if we figure out that whenever I reply in this way, the user does not like it, then the system can actually quickly self-improve. We use some of the self-improvement techniques to build the systems. On the other side, humans are not really good at making global optimizations. So some of our local feedback may not be very useful for the task success. So it's really hard to kind of balance between this kind of local feedback and fast improvement versus maintain some kind of global optimization. I think that there is a question there.
Yes. Can on-device inference prevent like leakage risk?
That's a good question. So I think on-device will help with like fast inference when it comes to specific applications. But as long as the agent has access to like local data, local users' data in multiple sources, then it's very likely that there may be some kind of unintentional leakage. So one of the issues we run into is that, let's say the agent is working on your phone and has access to your health record, your financial record, your DoorDash, and other kind of things. And then certain kind of actions may be influenced because the agent has access to different type of information source. So when they are making decision in a specific context, the do not have a very good kind of boundary control of where the information comes from. As a result, they might be using information that's not supposed to be known for the current application. So I think with a lot of the mobile apps, you already have this kind of like very app-specific control. Such concept for agents is not very clear today. As a result, you may still run into an intentional risk of privacy leakage.
Okay. All right, thank you so much, Professor Ying.